There is a set of original architectural drawings held in the New York Public Library's map and plans collection. They date to 1906. They belong to one of the civic buildings constructed during the Great Beaux-Arts period, that era, roughly 1885 to 1925, when American cities decided their public spaces should feel like something. The drawings are meticulous. You can read the structural annotations in pencil. You can trace the coffered ceiling profiles. And in the margins, in a neat, slanted hand, are numbers. Those numbers are the part that stopped me. Not the floor plan dimensions, those you expect. It's the ceiling height specification for what the drawings call the public concourse. The number written there is not 10 feet. It is not 12. It is not even 14. It is listed as 55 feet from finished floor to the crown of the vault, 55 feet. For a space where people wait for trains. Now, you can look at that number and say Beaux-Arts excess, classical posturing, an era that overbuilt everything for the sake of grandeur. That explanation is available, and it is not wrong, as far as it goes. But then you start reading the notes alongside the number. There is a notation common in the architectural drawings of this period that references a proportional rule tracing back through the École des Beaux-Arts in Paris, directly to the 16th century Italian architect Andrea Palladio. The rule is not aesthetic, it is mathematical. It relates the length of a room to its width, and both of those to the height of the ceiling, using one of three mean calculations: arithmetic, geometric, or harmonic, depending on the intended use of the space. The ceiling height was not chosen to impress, it was derived, calculated from a formula that assumed human beings belonged in rooms where the vertical dimension carried its own logic. I found these drawings because I was looking for something else entirely. The mainstream account of ceiling heights goes roughly like this. Old buildings had high ceilings because they had to. Before mechanical climate control, tall ceilings allowed hot air to rise away from occupants. Coal and wood fires produced smoke and combustion byproducts, and vertical volume helped disperse them. In public buildings, large crowds generated significant body heat, and again, height was a passive ventilation strategy. In civic and institutional buildings, courthouses, libraries, train stations, post offices, high ceilings were also a deliberate signal of institutional authority, civic pride, and permanence. Tall rooms meant important rooms. The Beaux-Arts style, which dominated American public architecture from the 1880s through the 1920s, drew on French academic traditions rooted in the Roman imperial aesthetic. Height was a language of power. After World War II, that language changed. Mass housing demands, material scarcity, and the industrial standardization of lumber drove ceiling heights downward. The pre-cut stud length of 8 feet became universal. Drywall panels were manufactured in 4 by 8 foot sheets to match. A feedback loop formed between material dimension and architectural norm. 8 feet became code, 8 feet became standard, 8 feet became, in the minds of most people alive today, simply what a ceiling is. That account is true as far as it goes, but it is incomplete in ways that matter. What it does not explain is why the proportional systems used before the 8-foot era existed at all, what they were actually calculating for, who developed them, across how many centuries, and what was lost when they were abandoned, not gradually, but in a single generation, for reasons that had nothing to do with human proportion and everything to do with industrial efficiency. Here is what the records actually show. In 1570, the Venetian architect Andrea Palladio published I Quattro Libri dell'Architettura, the 4 books of architecture. It became one of the most influential documents in the history of Western building. It was translated into English in 1715 and republished in 1738. Every architect trained at the École des Beaux-Arts in Paris, which is to say nearly every architect who designed any significant American civic building between 1880 and 1920, was trained directly in Palladian proportion. Palladio did not guess at ceiling heights, he derived them. His system stated that the height of a room should be calculated as one of 3 mathematical means between the room's shorter and longer floor dimensions. His arithmetic mean produced a ceiling height equal to half the sum of the width and length. His harmonic mean, his most elegant formula, produced a ceiling height that maintained a specific mathematical relationship to both dimensions simultaneously. He gave an example. A room 6 feet wide and 12 feet long receives a ceiling height of 8 feet by his harmonic calculation. This is not ornamentation, this is geometry applied to human occupation. And it was not Palladio's invention alone. He was drawing on Vitruvius, the Roman architect, whose De Architectura, written in the 1st century BCE, itself claimed to be encoding principles even older. Vitruvius anchored all proportion to the human body, specifically the proportional relationships between limb lengths, body height, and the span of outstretched arms. The system did not assume a particular height for a room. It derived the appropriate height from the room's other dimensions. A small room should have a lower ceiling, a larger room, a higher one. The relationship was fixed by mathematics, not by taste. Now, carry that principle to the buildings. We have the main concourse of Grand Central Terminal, completed in February 1913, and designed by the firms Reed and Stem and Warren and Wetmore, both Beaux-Arts trained, has a ceiling vault measuring approximately 25 feet at its crown. The main waiting room of the original Pennsylvania station, completed in 1910 and designed by McKim, Mead and White, also École des Beaux-Arts trained, measured 314 feet long, 108 feet wide, and 150 feet tall. Those numbers are in precise Palladian relationship to one another. The room's proportions were not decorative choices. They were the output of a formula that had been in use, with minor variation, for roughly 1,900 years. The average British man in 1870 stood approximately 5 feet 5 inches tall. He was not being given a 150-foot ceiling because of his stature. He was being given it because the proportion of the room demanded it, because the architects had been trained in a system that held that to violate the proportional relationship between floor and ceiling was to violate something about the experience of being human inside a room. That should have remained the standard. It did not. Here is what happened. And here is the part I keep returning to. World War II created a housing crisis on a scale the United States had never faced. Millions of servicemen returned between 1945 and 1947. Birth rates surged, urban rental markets were saturated. The federal government, through the Federal Housing Administration, established in 1934 and dramatically expanded after the war, began guaranteeing mortgages for suburban single-family homes on an industrial scale. Builders like William Levitt, who had refined prefabrication methods during wartime military construction, applied the same logic to civilian housing. At Levittown, New York, begun in 1947, Levitt's crews were producing 30 houses per day at peak construction. The model required absolute standardization of every component. Among those components was the wall stud. Pre-cut studs, manufactured to a nominal 8-foot length, had been circulating since the early 20th century. But after the war, the American lumber industry, coordinating through organizations that would later consolidate into the American Lumber Standard Committee, locked 8 feet as the effective universal standard. Drywall manufacturers followed, producing panels in 4 by 8 foot sheets to fit the new stud grid. A 1938 modular coordination program, developed by engineers and industrialists, later folded into what became the American Standards Institute, had already laid the conceptual groundwork. The result was a closed loop. Studs, panels, and code minimums all reinforced the same dimension. By 1950, the 8-foot ceiling was not just common, it was for practical purposes the only ceiling being built at scale. This is not a conspiracy in the dramatic sense. It was something more durable than a conspiracy. It was convergent interest. The lumber industry wanted to sell standardized material. The building industry wanted to reduce variable cost. The mortgage industry wanted predictable construction. The federal government wanted to house a population as fast as possible. No single actor decided that the Palladian tradition should end. Each actor simply optimized for their own interest. And the accumulated result was a civilization-wide reduction in vertical space that has never been reversed. The obvious objection is, this is just the history of industrial standardization. Every product got standardized after the war. Car dimensions, appliance sizes, road widths. None of this is sinister. That objection is correct. And it is also part of the argument, because standardization of ceiling heights was not the same as standardization of a refrigerator dimension. A refrigerator is a product. A room is an environment that a human being lives inside for years. The Palladian tradition and the Vitruvian tradition before it held that the proportional relationship between a person and their enclosing space was not arbitrary, that violating it produced environments that felt in ways that were difficult to name but impossible to ignore, diminished. The research traditions that might have quantified this, environmental psychology, architectural neuroscience, largely did not exist in 1947. The decision to standardize was made before the question of its human cost was even formulable. What was lost was not just ceiling height as a measurement. What was lost was the assumption that the vertical dimension of a room had a meaning, that it was in dialogue with the floor area beneath it, according to a formula that had survived from Rome through Venice, through Paris to the public buildings of every American city. The New York Public Library's main reading room, completed in 1911, has a ceiling height of 52 feet 16 meters. In 1930, approximately 4 million people visited it annually. It was designed not to impress them, but to give them the proportional experience that Palladio's harmonic mean, applied to a room of that footprint, produced. No public building built in America after approximately 1955 was designed according to that principle, not one. His name was Charles Foller McKim. He was born in 1847 in Chester County, Pennsylvania. He studied at the École des Beaux-Arts in Paris from 1867 to 1870. He returned to New York and, with partners William Meade and Stanford White, built one of the most influential architecture firms in American history. His buildings include the original Boston Public Library, the Columbia University campus, and the original Pennsylvania Station. McKim died in 1909. He did not live to see Penn Station open. It opened November 27, 1910. He spent the last years of his life in deteriorating health, partly in an institution, but he had seen the designs completed. He had approved the specifications. The main waiting room, 314 feet long, 108 feet wide, 150 feet tall, was his. The Corinthian columns, each rising 84 feet, were his. The honeycomb coffered ceiling was his. The travertine sourced from Campania in Italy was his. Every dimension derived from a proportional system he had learned in Paris, which had been taught without interruption for over 2 centuries, which had come from Palladio, which had come from Rome. He built a waiting room for train passengers, not for royalty, not for heads of state, for the people of New York City arriving and departing. The architectural historian Vincent Scully would later write that to enter New York through the original Penn Station was to enter the city like a god, and then, when the station was demolished between 1963 and 1966, Scully said, "One entered the city like a god, one scuttles in now like a rat." The demolition began on October 28, 1963. A light rain was falling. The wrecking crews removed the 84 Doric columns, 16-ton Doric columns, from the exterior. They broke apart the marble walls. They dragged the fragments to the Meadowlands in New Jersey. McKim's floor plan, with its margin notations, its careful proportion calculations, is still in the archive. The room itself is gone. Penn Station was not unique in what happened to it. The old post office building in Chicago, the United States Post Office at Canal Street, completed in 1921. Also Beaux-Arts, also proportioned with ceiling heights between 30 and 60 feet in its public halls, was partially gutted in the 1990s during a renovation that subdivided its grand interiors into low ceilings office floors. The building's exterior survived. The proportional interior did not in Washington, D.C. The original Bureau of Engraving and Printing facility, constructed in 1878 on 14th Street, with ceilings in its public areas rising to approximately 20 feet, was modified in the 20th century to accommodate modern equipment and cubicle-based office layouts. The plan drawings exist in the National Archives. The spaces do not in virtually every American city. The period from roughly 1955 to 1980 saw the demolition or internal subdivision of civic and commercial structures built between 1880 and 1930. The mechanisms varied: real estate pressure, deferred maintenance, urban renewal policy, the economics of commercial tenancy that made subdivided low-ceiling floors more profitable than single large-volume spaces. In some cases, entire city blocks of Beaux-Arts commercial architecture were cleared. In others, the shells survived while the interiors were gutted to modern specification. The individual cases each have a conventional explanation. Together they describe something else. They describe a systematic withdrawal from the built assumption that proportioned vertical space had value, not aesthetic value alone, but functional, experiential, perhaps physiological value, a value that architects had been taught to calculate for roughly 2,000 years, and that builders stopped calculating almost overnight. The connection to modern life is direct. The average American today spends approximately 90% of their time indoors. The dominant indoor environment is not a public building with a 52-foot reading room ceiling. It is an 8-foot residential space, a 9-foot office floor, a 7-foot retail aisle, a fluorescent lit corridor that touches your hair. The question of what proportion space does to a person's interior life over decades, their concentration, their sense of possibility, their sense of their own scale within the world, is one that environmental psychology researchers at institutions, including the University of Minnesota and University College London, have begun to investigate in the last 20 years. The evidence still accumulating suggests the question was worth asking all along. None of these records are hidden. They are simply never placed next to each other and read in sequence. The original Palladio proportional rules are in I Quattro Libri dell'Architettura, available in translation at most university libraries and through several digitized archives. The McKim, Mead, and White architectural drawings are held at the Avery Architectural and Fine Arts Library at Columbia University. The American Standards Institute Modular Coordination documentation from 1938 is accessible through the ANSI archives. The demographic and housing construction data from the post-war period is in the collections of the National Archives and the HUD Office of Policy Development and Research. The Penn Station demolition protest records, picket photographs, and petition documents are in the collections of the Museum of the City of New York. What was lost is easier to measure than what it cost. We can measure the ceiling height of the original Pennsylvania Station main waiting room. We cannot measure what it meant to a person from a tenement apartment on the Lower East Side in 1912 who walked into that room for the first time. We cannot measure whether it changed something in how they understood the city they lived in, whether it made them feel, however briefly, that the city had built something for them. Not for commerce, not for power. For the act of waiting, the proportional tradition did not claim to make people better. It claimed only that there was a right relationship between the size of a room and the size of a human being, a relationship derivable by mathematics, legible in the body, and worth preserving. That claim survived 20 centuries of architectural practice. It did not survive the 8-foot pre-cut stud. The loss is not only aesthetic, it is categorical. An assumption about what architecture is for, about whether the space you inhabit is in any meaningful relationship with you, or simply an efficient enclosure, was quietly abandoned. For reasons that were never architectural, in a decade that did not quite notice what it was doing. If documented hidden history matters to you, stay with this channel. The original floor plans still exist, the notation systems still make sense, the Palladian proportional rules still work. There is no technical reason in 2026 why a public library or train station could not be built according to the same system that McKim learned in Paris in 1869. The mathematics has not changed. What has changed is the assumption that the mathematics matters. And somewhere in that change, in the gap between a 150-foot waiting room and an 8-foot ceiling held up by a pre-cut stud, is a question about what we decided we were worth. That question is still open.